Rationalizing denominators, algebra 2 trigonometry regions. Write in simple radical form. That's kind of a strange way of saying that. Wouldn't it be simplest radical form? But anyways, 1 over rad 5. The issue here is we're very picky about our denominators. Remember, that's the bottom of the numerator on the top, denominator on the bottom. Like you remember that we can't have, something over 0. We can't have, that's called undefined. You can't have 0 in the denominator. We're picky about our denominators. And so we like our denominators to be rational. And something like the square root of 5, well, that's not rational. Like when you type in the square root of 5, this is not a rational number. The decimal stops because your calculator screen ends. It goes on and on and on and on and on and on to infinity. Um, so just like we don't like to have a 0 down here, we don't like to have an irrational expression down there either. And so we need to what we call rationalize the denominator. That's the title here, rationalize denominators. Because, we can't divide something irrational by, well, I'm sorry, I'm saying that backwards. We don't want to divide something rational by irrational, but it's okay the other way around. Kind of like with 0, like we can't, divide something by nothing, but you could divide nothing by something, which, we could get into a philosophical conversation about why, but we don't want to have a radical on the bottom is really the gist of it. So how do we go about getting rid of that down there? And the procedure in this case is to actually multiply the top and the bottom by that radical. Because if you remember from an earlier class, we know that rad 5 times rad 5 is not a radical. It's just 5, because it'd be rad 25, which is 5. So multiplying a radical by itself eliminates the need for that. So we end up with 1 rad 5. So you end up with, you could put 1 in front of it, but rad 5 over 5, and that's okay. That's the answer. We can have a radical on the top, just like we could have a 0 on the top, but we just can't have it on the bottom. For the second one, this whole thing's under the square root, but if you remember what we did when we do square root of fractions, you do the square root of the top, and you do the square root of the bottom. In this case, the top is a square and becomes 5, but the bottom would have to stay rad 3 because 3 is not a square. 25 is, but 3 is not. And so now to rationalize it, I'm going to multiply the top and the bottom by that radical 3 to get 5 radical 3. Because remember, 5 times radical 3 from the last lecture, I can't multiply, like it's not rad 15. They're not both radicals. So it's like 5 times x is 5x. So 5 rad 3 is 5 rad 3. And on the bottom, rad 3 times 3, rad 3 is 3. So 5 rad 3 over 3. There we go. All right, this one's a little bit more complicated because now we got variables involved, and this kind of looks like one of the division problems. Why can't we just divide these? Well, you could divide 6 by 3, but x divided by x to the 5th, that's not going to work out really well. We'd actually end up with still a fraction and so on and so on. So the easier approach in this scenario is to do what we did in the last two examples, multiply the top and the bottom by this radical, as complicated as it is. So we're going to multiply the top and the bottom by radical 3x to the 5th. The bottom will simplify to be 3x to the 5th. The top, now multiplying radicals we did yesterday, we can do that, so that would end up being rad 18, right? 6 times 3. X to the 1st, x to the 5th multiplies to x to the 6th, and y to the 2nd is still y to the 2nd. But now I need to simplify this whole thing up here. All right, so let's see, the 18, I'd use 9 times 2 to get 3 rad 2. X to the 6th, I'm doing square root, so I divide by 2, and 6 divided by 2 is 3, no remainder. And y squared, 2 divided by 2 is y to the 1st, no remainder. So only thing that's left inside is that rad 2 over 3x to the 5th. However, I'm still not done because now I can simplify. I can get rid of these 3's. I have 3 x's on the top, 5 on the bottom. I can cross out all 3 on top, and I'm going to be left with 2 x's on the bottom. And so I have a y to the first and a rad 2 over x squared. And let me write this a little bit differently. Y rad 2 over x squared. And let's see, is that over here? Yeah, I don't like that they have the y after the rad 2. I would put it in the front, but that is what they were looking for. All right, this next one is slightly different. It's different because rad 7 is not the only thing down here. There's a 3 minus radical 7. And if I were to just multiply by rad 7, I'd have to distribute, and that would end up getting me 3 rad 7 minus 7, and I still have a radical on the bottom. So we need to do more. We need to do what we call is multiplying by the conjugate. Conjugate. And that is going to help us here. The conjugate of 3 minus rad 7 is 3 plus rad 7. And so notice what's similar, but what is different between these. So these are conjugates. And the first term is exactly the same. The first term of both is 3, positive 3. So same sign, same number. But the second term are additive inverses. Negative rad 7, positive rad 7. Why is this going to work? Well, now first of all, we'd have to do it on the top and the bottom. So let me just write that up here too. 3 plus rad 7. The reason why it's going to work is kind of like when you FOIL or distribute a difference of two squares. It's not a trinomial. Like if you have x plus 2 times x minus 2, you get x squared minus 4. Well, how come it's not a trinomial? Because that middle term cancels out. Because you'd have positive 2x and negative 2x, and they cancel each other out, so it's just this. That's kind of what's going to happen here, because if we were to look at all four terms here, 3 times 3 is 9, and 3 times positive rad 7 is positive 3 rad 7, and negative rad 7 times positive 3 is negative 3 rad 7, and then negative times positive is negative, but negative rad 7 and positive rad 7 multiply to just 7. And so what do you notice happens on the bottom? First of all, our last term of radical times radical cancels out the radical, and it's not a radical anymore, it's just a 7. And the two middle terms do have radicals, but they are additive inverses, and they cancel each other out. So all I'm left with is 9 minus 7, which is 2. And so I no longer have a radical in the bottom. And so that's why conjugates work in this scenario. At the top, I would multiply to, I would actually distribute this out in most cases and get 3a plus a rad 7. But that's actually not what they're looking for here. They're looking for you just to kind of write it next to each other, and this would be the answer. In most cases, we do multiply it out. So let's look at one more example of this. So 5 minus rad 2 over 3 minus rad 2. The bottom is the issue. I can't have a radical down here. Remember, radicals on top are just fine. And because this is a binomial, polynomial, I need to multiply by its conjugate. If it was something like just, rad 3, a monomial, I just multiply by rad 3. But when it's an expression, rad 3 is also an expression. But when it's a binomial like this, you got to use conjugates. So 3 plus radical 2 is the conjugate of 3 minus rad 2. The only difference is the sign in the middle. The top, I do not do the conjugate of the top. I'm still doing the conjugate of the bottom. Because remember, we multiply the top and the bottom by the same thing. I've seen students make that mistake where they put 5 plus rad 2 here. That's not what we're doing. It matches what we'd multiply down here by. So when you multiply to change a fraction, you have to do the top and the bottom the same. What's up top is like what we were doing yesterday, multiplying radicals. These are not conjugates up here, so I have to do all of this work here. So let me change my color to green and do 5 times 3 is 15. 5 times rad 2 is 5 rad 2. Negative rad 2 and 3 is negative 3 rad 2. And positive rad 2, negative rad 2 is minus 2. And some stuff will cancel out here. I have a 15 and a minus 2, which will give me 13. I have a positive 5 rad 2 and a negative 3 rad 2, which is going to be positive 2 rad 2. And then the bottom, now I could distribute or FOIL this whole thing out, all four terms, but when you know it's a conjugate, that means you know your middle terms are going to cancel out. And so you don't have to waste your time with all four terms if you know the middle ones are going to cancel out. All you really need are the first terms multiplied to 9 and the last terms multiplied to minus 2 over 7. Because otherwise I'd have a positive 3 rad 2, a negative 3 rad 2, and they would cancel out. And since I know that's going to happen anyways, why would I waste my time? And here's my final answer. And that's the final answer to the problem. Now, you always want to re-examine this and see if it can be simplified. Remember, if all three of these numbers can, if we could divide and simplify further, we'll look for that, and maybe we'll see that tomorrow in class. But this is an important concept, multiplying with conjugates, and we'll see this again a few times throughout the year. All right, we'll practice this tomorrow in class.